Hi viewers, welcome to LMS Solution. Today we are going to see about MATLAB simulation of solar powered EV charging station. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for a notification about upcoming videos. So this is the block diagram for a solar powered EV charging station. So this block diagram consists of PV array along with the DC-DC converter and the MPPT algorithm, and then standby storage element, so nothing but battery storage, stationary storage element along with the bidirectional DC-DC converter with some voltage controller, and it have grid integration, grid supply, and then it has EV battery with the DC-DC converter. Okay, so in this block diagram, that means what's the working of the EV charging station, right? So whatever power available in the PV it goes to charge the stationary storage element, and also whenever the EV connected to the charging station, right? Then it going to supply the power to the EV battery as well as going to charge the battery. And if suppose there is no power in the PV, the power generation, there is no power generation in the power PV panel. Okay, during that time the battery going to be supply the power to the charge the EV battery. And if suppose there is no power in the PV, and then the SOC of the stationary battery storage element is very low, then we can get the power from the grid to charge this stationary battery as well as charge the EV battery. And also if suppose we have excess power in the solar PV system, and then the battery SOC of this battery, that means we have enough charge in the battery, then during that time this going to be this both the PV and this stationary storage going to be supply the power to the grid as well as charge the EV batteries. Okay, so this is working of this solar powered EV charging station concept. That means, so by using this solar PV array, we are going to charge the battery. So this is ultimate aim of this work. Okay, so today we are going to see about the MATLAB implementation of this solar PV powered EV charging station. So let's start with the simulation. So this is a simulation we created for a solar PV powered EV charging station, right? So it consists of solar PV array along with the boost converter, right? So this is solar PV array, and then this is boost converter. Okay, and then we are using ANFIS MPPT here. So this is ANFIS MPPT. So this receive two inputs. So one is irradiation, another one is temperature. So based upon this irradiation temperature, it provide the voltage at maximum power point. Okay. So here we are measuring the PV voltage. So this PV voltage compared with this voltage from, that means voltage reference from the ANFIS controller, and then it's going to be processed via PA controller, and then process via PWM generator to generate the pulse for this IGBT to extract the maximum power from the PV panel. Okay. So here we have another block, scope block, right? So this is used for measuring the PV voltage, current and power. Okay. So this is the arrangement of that solar PV system in the solar powered EV charging station. So next I'm going to explain about that battery. Okay. So this battery going to be stationary. This battery going to be act as a stationary storage battery. Is connected via bidirectional DC-DC converter, and then here we are using voltage control method to maintain the DC bus voltage around 500 volt. Okay, so we are going to measure this DC bus voltage and it's going to be compared with 500, and then going to be processed via PA controller, the PWM generator. It generates the pulse for this bidirectional DC-DC converter. Okay, so it's going to control this IGBT and have to maintain voltage 500 here. Okay, so this battery going to act as a stationary battery, the simulation model, and here this one going to be act as a EV battery. So this is also connected via bidirectional converter along with the voltage control. So here also we are going to measure the same bus voltage, and then is compared with the 500 volt reference, and then going to be processed via PA controller and PWM controller. So it will generate pulse for this IGBT. So based upon this, it going to be maintain voltage across this DC bus, as well as it will take the power from that DC bus. Okay. So here we are having the measurement unit. That when here we are measuring battery voltage and current. Here we have to measure SOC, and then here we are going to measure the EV battery voltage and current and SOC of the battery. So finally we have see the SOC of the battery in this code. Okay. So next we are going to discuss about grid. So here we are going to use single phase grid. Okay. So this is single phase inverter. So connected to the grid via LCL filter. Okay. So here we are going to measure. I am going to measure grid voltage and then inverter current. So based upon grid voltage and inverter current, we are going to share the power from the grid and then to the grid. Okay. So first you have to generate omega t based upon the VG by using PLL. After that, we are going to generate in grid control, right? In grid control, we are going to use neural network concept. Neural network going to be used for generating the reference current. So based upon PV power and the SOC of the stationary storage battery. Okay. So the neural network receive these two input, SOC of the battery and then PV power. So based upon these two input, this neural network generate a reference current. Okay. So this reference current going to be converted into dq naught, and then actual inverter current going to be converted into dq naught, and then it's going to be converted here. After that, it's going to be processed by a PID controller. Then it's going to be once again converted into dq naught to alpha beta naught, and then we are going to take only alpha quantity to generate the pulse for that inverter. So this pulse is going to control the inverter current flow. Okay, based upon this reference current from the neural network. So this is a Simulink model we have created for this solar powered EV charging station. It have an ANFIS MPPT and then neural network based energy management system for a grid integration. Okay, so now I'm going to set the, here you can see that the SOC of the battery is around 90%. That means SOC of this stationary storage battery 90, and then so SOC of the EV battery is 9%. So next you have to see the simulation results. So now you can see that the PV power is around 2000, right? This SOC, that means this one known as stationary battery voltage and current. So because of 90% SOC, right, the battery goes to discharging mode. Okay, so and also you can see that the PV power have around 2000 watts. So now we can see that this is a grid current and then this is inverter current. Now you can see the SOC of the standby battery is decreases from 90% because it is in discharging mode. And then you can see this, this is EV battery. So this EV battery voltage and current. So the EV battery current, you can see that is minus. Okay, so minus 30, that means in charging mode. So here you can see that the SOC of the battery start increasing here, EV battery. And here you can see that the grid power is around minus 200. That means minus 200 means is taking power from the solar PV and battery. So now you can see that the solar PV power is changed from 2000 to 1000 because of changing irradiation. So because of that, what happened to the battery current? You can see that battery current also decrease here, and also the sharing of power to the grid, right? The power here now you can see that this comes to around 400 watts, right? So the grid receiving only the power around minus, that means 400 watts. Okay, so still that the EV battery is in charging mode, right? Here you can see that it still receive the current around minus 32 amps, right? Still in charging mode. So here you can see the SOC of the standby battery and the EV battery. Now you can see that PV power, right? The PV power is comes to less than, it's around nearly 500 watts, right? So now you can see that power uh, feed to the grid is equal to 0. Okay, so here you can see that this is the current of this grid and the inverter current. So this is a SOC battery current, that means SOC of standby battery current. So SOC, sorry, this is the uh, current of the standby battery. This is the current of the standby, sorry, EV battery. So for changing, that means changing irradiation condition, we check the results now. So now you can see that now the PV power comes to less than around 200 watts, right? So now you can see that grid now goes to supply that. That means grid now supply the power to the DC bus. Okay, here you can see that the grid power goes to power positive. That means we are taking power from the grid. Still the standby battery supplying the discharging, and the EV battery is charging mode condition. Next you have to check the process. Once again the PV power comes to some low value. So because of that, what happened? The grid comes to supply the power some amount according with the PV power reduction, right? Still this battery, that means stationary battery discharging, EV battery charging mode condition, right? So this is the working of this model with the condition. The SOC of the storage battery is 90 percentage and the EV battery is 9 percentage. So now I am going to change the SOC of the stationary battery equal to 40 percentage. Okay, and then once again I am going to simulate this model. Now we can see that so PV power is 2000, same condition if we change according with the radiation. Okay, so now we can see this battery current of the stationary battery is in positive, that means it is in discharging mode, and then here you can see that EV battery current is minus, that means in charging mode. So here you can see that the power is minus, okay, minus 900, that means we are, that means the solar PV battery going to supply the power to the grid. And also you can see the SOC of the battery. So the standby batteries SOC is decreasing and EV battery is SOC is increasing nature, that means charging mode condition. Now you can see that based upon this PV power, right? So now what happened, that is the PV, that means grid going to comes to supply the power to the DC bus. Okay, the power sign is changed to positive, that means solar PV, that DC bus system is receiving the power from the grid. So this is variation of grid voltage and grid current and inverter current. This is DC bus voltage. This one DC bus voltage, grid voltage, grid current, inverter current. So based upon this PV power, right, the grid sharing the power, right, grid supply the power. So based upon this PV power, still that EV battery charging condition, so the current flowing through the battery is negative. Negative means it is in charging mode. So you can see in the SOC graph, right, the SOC of the EV battery is still in increasing manner, right? Now the battery power is decreasing because of decreasing radiation. Now you can see that the sharing of grid power, the grid supplying the power to the DC bus. So because of increasing in DC, that means grid power, right? The grid supplying the power, you can see the sharing of storage battery, the current also decrease, right? Because of this sharing of grid power, right? So this is another condition we discussed now. That means now the condition is SOC have 40 percentage. That means storage battery have 40 percentage and EV battery having less than 10 percentage, right? So this is a result of this condition. Okay. So next I'm going to change this battery percentage to 10. Okay. That means stationary battery SOC is 10%. Now I am going to simulate this model. Now we are going to check the performance of the solar powered EV charging station concept. Now you can see that SOC of the standby battery and the SOC of the EV battery is keep on increasing. Okay, because both goes to charging mode, because both are having around 10% of SOC. Now we can see the performance of the grid side also. Now we can see that now grid supplying the power, right? Grid supplying the power, solar PV supplying the power to charge the standby battery as well as EV battery. Now power is the solar power is decreasing because of decreasing radiation. So based upon the condition, the grid supplying the more power. Okay, this one still storage battery current is negative and EV battery current is negative. Still the SOC of the standby battery and EV battery is increasing nature. That means in charging mode. So this is sharing of current of inverter, that means grid. Next you can see that, so here now the PV power is decreasing because of decreasing radiation. So now you can see that the because of decreasing PV power, the grid power is increasing now here. So still you can see that storage battery current is negative and EV battery current negative. So both are in charging mode. So battery current is increasing, keep on increasing. It's based upon power from the PV and the grid. So how now we can see that the power is decreasing here, PV power. So here you can see that the power is increasing in the grid side. That means grid supplying the more power. So this is the working of this solar powered EV charging station. So this model have ANFIS MPPT and neural network based energy management system. So this neural network receive two inputs, SOC of the standby battery and PV power. So based upon this, it will generate the current reference. So based upon the current reference, this inverter will supply the power to the DC bus or receive the power from the DC bus. Okay. So this is the working of solar PV powered EV charging station. Thanks for watching our videos. So